Hey everyone, welcome back. In this video today, let's see what HTTPS is. Just in case if you have not heard it or seen it. So when you go to a particular browser in your computer, let's take this as your monitor, right? It can be your Internet Explorer or Google Chrome or Firefox. So you open one of your Internet Explorer, often you see a search box. It can be in the center or top based on the UI. So you when you type a URL, for example, you're gonna shop something in Amazon. So you type www.amazon.com, and when you click enter, so immediately you can see like a small lock symbol appearing here. So if you click on that, it will say that connection is secure. If you haven't noticed this, this is a fun part. You can check next time when you hit any URL. A lock usually appears for most of the websites you visit, and when you hitch over it or click on it, it will say connection is secure. Connection is secure. And when you right click on it now, the www.amazon.com, or in the search bar, you usually see HTTPS added to it. So usually this is the visible part, but when you click on it, it will show here as well. So let's see what HTTPS is real quick. So HTTP, we can isolate this and then we can see what S means. So HTTP means hyper text transfer protocol. So this is a protocol just like in real world. You can assume it like a set of rules that helps two people to have a communication or an agreement kind of thing. So in the internet, this is your system, and obviously there is an Amazon computer there. We know that Amazon, we have an Amazon computer. So when these two computers interact, they need to have a way to interact. For example, when you hit pay here, right? You went to the shopping cart, you have the amount here, you have given your credit card number and your CVV, and you hit your pay button. So basically, you send that information to Amazon. This is my amount, 500. This is my card number, 123 dot 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 dot, and this is my CVV, which is usually four numbers, right? It's 456, for example. So how you send this? Hey, this is my request. I want to pay 500, and this is my card details. So the way you are sending this request is defined by this protocol. This is not exactly the same how it is, but both this system, your computer and Amazon, has to understand something, that this is the request, and that set of rules is called HTTP. This is a commonly used protocol in the internet when two systems communicate via internet. So what is this S part? So the S part, as your browser mentioned, it means secure. So what does the secure basically do is that, so you see some information that is being sent from your computer to Amazon computer, so that Amazon can use your information to complete the payment, right? what this yes does, if it says HTTPS, is before this information leaving your computer, this gets converted into a scrambled text. For example, amount will be like x754, colon will be like question mark, and it will be like 7ab. So when you see from outside, there is no sense between this and this. So it basically scrambles or encrypts the entire data into some random things. So this process of converting whatever information that you send from here into a scrambled text is called encryption. We saw this in the WhatsApp video, that WhatsApp does this before your messages reaches the WhatsApp. And when you do this at the Amazon end, it of course doesn't need this. It wants this so that it can complete the payment. So Amazon will decrypt this back to this, or descrambles it. So this part where you convert the encrypted text back to the plain text is called decryption. So there is a lot of ways how this can be done by encrypting and decryption, and how these two systems first of all communicate and say, hey, okay, I am Amazon, okay, you are this mobile device, you want me to communicate securely, okay, let's do encryption and decryption, let's have a handshake. So that kind of rules also comes in with respect to only making it a secure communication, not with request, with respect to how the request looks like and how the response looks like. So that set of rules is usually called TLS with respect to HTTPS. So the protocol that followed in HTTPS is TLS, that also includes encrypting your plain text into this and then decrypting your scrambled text into plain text, right? So this is basically what HTTPS support. It makes sure that it is, the communication is more secure. So coming to that part, so by scrambling this and again decrypting at it, what is the major advantage? Why do we make a lot of emphasis or give more importance to the fact that it needs to be HTTPS and only then the connection is secure, right? It is straightforward. I am a system, I am sending some details to Amazon system, which I trust. Amazon is good, right? They are going to handle this properly and they are going to keep it securely. I believe in Amazon. Then why do I need to do this, right? So to get a idea on that, so before your request reaches your Amazon, there is a lot of hops that happen in the internet, or to make sure that your request passes through the network. So let's have a like a sample number of hops that happen. So it starts from your mobile. Say you are using your Wi-Fi to send the request. So obviously there is a Wi-Fi network which we saw in the public IP private IP video if you haven't watched it. So this is your mobile, this is your Wi-Fi router, and from Wi-Fi router it goes to your internet service provider. It can be Airtel, Verizon, BSNL, Spectrum, whatever it is. ISP. And from here, based on where your target mission is, in this case Amazon, a lot of routers or switches are along the way, which helps you to navigate the request to your target computer. It can be out of your country as well. So this will help you to make the hop to your final target mission, right? So this is usually called as internet backbone. I am assuming this name is given because of the amazing job it does to take the packets from one place to another. And finally is your target machine, which is Amazon. So as you see, there are a lot of hops happening. If your information is in the plain text, it can be visible to anyone if they have access to this. For example, from your mobile, how the data goes to your Wi-Fi router is basically it broadcasts your information through the air. So any hacker who has access to your Wi-Fi network can basically read this message. Of course, they need to be competent, but they can basically read this message or tap into this message and see, okay, what this person is sending and sending to whom, right? So we don't want that hacker to get our CVV or amount or card number, because these are very secure information. If your CVV gets leaked and card number is there, pretty much they can use it for anything to purchase. Of course, there are other security, like if you have configured limits or something, that will help, but still there is a chance that your card is misused, right? Usually the internet service provider, internet backbone, these things are safe. Usually people don't do any fun things over there, but still there are people working there and they have the competency and the access to tap into the message if they want to or if they try to, right? So that is the main reason why we convert this into an encrypted text, so that even if someone taps into it, all they see is this one, and they do not have the key to convert this to this. That key is only available with Amazon, right? So we know why it is needed, but in order to dive deep into why it is needed, I'll list down 3 points which TLS supports today, right? So the first thing is confidentiality. So basically this is what we saw. We don't want our messages to be read by anyone. So this will prevent something called sniffing, that is a hacker getting into your network and try to sniff your packet. And the second one is integrity. Say if a hacker tries to tap into your network and if they try to change something in your package, for example, your package looks something like this: transfer 500 rupees to friend. A hacker has tapped into this message and found a way to change this 500 to 10,000 and taking your friend's account number with hackers one. So basically when it reaches your destination, in this case it is not going to be Amazon, it is going to be your bank. So your bank will only see that if you have 10,000 rupees balance. As long as you have 10,000 rupees balance and this is a valid account number, they are going to believe that okay, this is a valid request and is going to transfer 10,000 to the hacker account. But in this case, when you follow TLS or when the connection is secure, even if there is a small change to the packet, the target will be able to assess it. So basically as part of TLS, they have algorithms. So when the request reaches, the scrambled text reaches your bank's system, it will try to use that algorithm to decrypt, and if it sees that there is any change in the packet, then it will not proceed with the request and it will drop the request. So that part, when this goes, the bank will realize that okay, this is not valid, I am not able to see what I am supposed to see, and it will drop the request. And the third one is authenticity. right? So by authenticity, what I mean is not everyone can go and say, hey, I can communicate with you with HTTPS. So when a particular organization wants to go and register their domain for HTTPS, they have to go to a certificate authority, trusted certificate authority. Hey, I am Amazon. You know that I'm a valid guy. So I'll submit these things to prove my identity, give my domain name or URL, a certificate so that I can prove to my clients that I'm a secure website and I can communicate via TLS, right? So when Amazon creates a website, it goes to this one of the trusted certificate authorities. You can have analogy with government officials kind of thing, and they will do all the checks and it will give them a certificate saying, hey, this guy is a valid website. So when you initiate a TLS, so basically that certificate is checked as part of the process, and only then the browser will start the communication with Amazon.com. So your browser and your operating system will have a list of trusted certificate within. So one of the organizations that does this certification or gives certificate is Interest, for example. So similarly, it will have a list of organizations which it can trust. So only when a website comes and gives you a certificate which is provided by one of these authorities, it will give you this lock. So if this lock is there, then you can believe that, okay, this is a website which is approved by one of these authorities. So I can believe that if it says Amazon, it is Amazon. For example, we know that the domain name of Amazon in India is www.amazon.in. Say I create a new website here and name it as www.amazonindia.com, and I have made it exactly look like Amazon, and then I have sent you some email advertisement saying that, hey, Amazon is hosting a sale in this website alone, so it is only available for Saturday. So when you go and hit this www.amazonindia.com believing my email or newsletter, so immediately your browser will not show this lock sign, it will take this S off, and it will say that, hey, I'm not able to identify the website, it doesn't have a certificate which I believe, so make sure that you trust it or don't proceed with the communication. So that is how you get the authenticity of a particular website using HTTPS. And that is pretty much it with HTTPS. I'll try to cover TLS on how this happens, how these two systems start communication, what and all happens to make sure that your system trusts Amazon, and how the required information transfers to make sure that you are able to make this into a scrambled text, and then how your bank will be able to descramble it. So all that comes part of the TLS. It is again a protocol which is called transport layer security, as I already mentioned, which I'll try to cover it in another video. Yeah, thank you so much for your time. See you in the next video. And of course, I would highly suggest that not to interact with any websites which doesn't allow HTTPS, which doesn't have a certificate, so that yeah, you can prevent yourself exposed to any attack in the internet, right? Yeah, see you. Thank you. Bye.